Hello and welcome to another episode of Laptop Retrospective. This is Think Design Stories. In this series, we will be going behind the scenes on one of the most iconic laptop brands ever conceived and is still going strong. Dr. Ted Selker creates and guides technological advancements. He often works as an advisor, chief scientist, and chief technology officer for startups. He also works on innovation and strategy for large companies. Ted is a prolific inventor, but especially loves working on concepts that have a large, positive impact. Some of Ted's AI and HCI research focuses on demonstrating considerate technology, which works to recognize and respect human intention in complex domains, such as kitchens, cars, and mobile and desktop solutions. Ted has worked on various technologies such as input and display hardware to AI for education. His successes at product creation and enhancement earned him the prestigious title of IBM Fellow. At IBM, he created R&D programs and was a senior manager of user systems ergonomic research. He worked across the company to foster innovative technology and business opportunities. He has also done innovative work at companies like Amazon, Xerox PARC, and Atari. As a CMU professor, Ted helped develop the graduate research program at Carnegie Mellon, Silicon Valley. Ted also created the Context-Aware Computing Group while also serving as a professor at the MIT Media Laboratory. He has had several positions and lectured at many other universities as well. The innovation Ted created and managed has been responsible for hugely profitable and award-winning products, ranging from notebook computers to operating systems. His visualizations have helped improve performance of the PowerPC, Google Maps, and usability of OS/2, and of course, ThinkPad. Ted not only created the TrackPoint, but also worked on tilting keyboards, cameras, sound systems, training materials, power supply solutions, keyboard illumination, concept computers, and much more. His adaptive help system has been used by tens of millions of PC users, and Ted's work has resulted in numerous awards, patents, and papers, and of course has been featured often in the press for these achievements. Well, thank you so much for joining me here today. Dr. Ted Selker, you're probably, just reading about you, one of the most creative thinkers I've ever had the opportunity to speak with, and I'm just really appreciative of you taking the time to spend with me to talk about some of the things that you have been up to historically and some of the things that you are currently up to, because I've learned one thing about tracking you down is that you have your hand in so many different projects, and I'm hoping to hear a bit about that from you as well today.
Well, thank you for interviewing me.
All right. So every story's got to start at a beginning. And I think probably a good place to begin with you is, how did your career begin? And I know that you had many kind of careers and you've jumped from project to project, but I know that IBM is kind of one of the places where things probably really started going for you, and the research center that you were a part of. Can you tell me a little bit about how you got involved with that and what that was like?
Well, I my first engineering job outside of interning at Weyerhaeuser, which was a lot of fun, and I did all sorts of great stuff there when I was in high school even, was Brown and Sharp. So they made precision tools and things like dial indicators and digital, everything, machine tools. And I spent a summer making something really, really cool, which was I improved the quality of one of their precision instruments by 10 times, doing some modeling and then demonstrating that it worked. And a lot of fun, but it was in Rhode Island and I hadn't quite finished my degree. And I remember when I left, giving everybody pictures. I was doing photography, a lot of photography then, and I gave people these framed pictures, kind of representing what what was appropriate I thought for them. And they gave me, somebody there gave me a picture back, framed picture of a clown, and I was kind of hurt because it was true that my reputation of always spilling out ideas and doing things in ways that weren't um, normal for them. Like I got in trouble for having an ice cream cone in my hand when I was on the machine shop floor. Um, um, that persona followed me, and I was sick of being called a flake, and sick of people thinking that I wasn't going to finish or follow through things, because I did. I mean, I rode a bicycle to Alaska when I was in high school. I mean, I made a sculpture for my mother's memorial that was several tons. So, but my persona brought out people giving me pictures of clouds. So I said, well, if I go work for IBM, that's a conservative place, which is so buttoned down. If I succeeded there, there aren't other people. Right? At Apple, there's lots of people that are creative. At IBM, not so much. What if I go to IBM and show that my creativity can matter? And that was actually my thinking. And I went and did it. It took a long time. It was very lonely. But it was really rewarding.
So, like, you got to IBM. Now, I imagine that they just didn't immediately put you in the research center, um, or did they? Maybe they were like, okay, we need to get this guy in here.
So what happened was I was on an interview with at a normal number of people to talk to in research around human computer interaction. And in the middle of that interview process, I'd given a talk about something called Dreamwriter, which was, I had an idea back then. This was early 80s, that a pen could be better at being a computer input and output than any computer, because at that point I had this idea that you never put down a pen. And what if you could rub that pen on an envelope and it'd address it? And what if you could be drawing something and it would help you draw it as though it was a CAD system on a piece of paper? And what if you could scan anything you wanted in with it? And what if you could, on a napkin, show somebody in a bar a picture of your girlfriend, right? By printing it, right? And so I had that whole stuff I was talking about. And so in the middle of my interview, the schedule changed, and suddenly I was in the C-suite with the vice president of engineering of research, and he said, "Look, Ted, the way you're thinking, other people aren't thinking around here like that. Why don't you just come here and do that?" And I said, "Really?" And I was at Xerox PARC at the time, by the way. I was already doing interesting things, and they offered me a year of freedom and the best computer on the planet, which was going to be a Xerox Dorado, and I was like, I'm in. The moment I arrived at IBM, my manager that was put in charge of me said, "Well, that's all good, but why don't you work on fixing the operating system for the PCRT so it can compete with the list machines like the one you want to buy? And you have to go to CMU to check this out." So I said, hang on a minute. I thought that I was going to get here and able to do an idea that I believed in. Oh, yes, yes, yes. But you could do that and you'd be all by yourself, or I'll give you 8 people to work on it for our product. And I said, I gotta try out this idea. I came here for a purpose. So I was all by myself. And that was a difficult time because I was all by myself. And while this vice president had my back, everyone between him and a normal person in research. By the way, I wasn't called a research staff member yet because I didn't have a PhD. I was called I can't remember what, but anyway. So everybody resented this, that I was taking this opportunity to use this freedom to try out my idea, which was at that time adaptive help, and I pretended I was going to make my PhD on that, and in fact I did. But that was a 7-year process. And by the way, by the time that Lou Gerstner, the CEO of IBM, came to my office, he flew out to see my lab, which was incredible. And I was so honored. At that point, when he walked into my lab, I said, I don't quite understand why my salary's gone up slower than inflation for the entire time I've been at IBM. And he turned white. And the reason that it had gone up that way is because it's very hard for organizations to value people doing things that are initiated by themselves, that are something no other people aren't doing, and are are going to change things. The reason he came out to visit was because I had made at least one difference that year, made the ThinkPad basically work, and it had created $500 million worth of business the first year. So that kind of surprised people.
Mm-hmm.
And at that point, of course, my career changed. Him visiting me and feeling that way lit a fire underneath all of these naysayers.
And from what I understand, and this is going to kind of dovetail into my next question for you, is that, for those people that do not know, you are the creator of the TrackPoint, like one of the most iconic, and I would argue one of the most longevitous, if that is even a word, but like one of the longest lasting input devices for a computer, because it, obviously introduced on the ThinkPad, but it is still being produced right now, which is like phenomenal. Like not even a trackpad has that kind of lineage
Yeah.
or heritage. How did you come up with the idea of the track point? Like, where did that come from? Like, I know you were working in human interaction, so I suspect it probably came from that.
So there's a bunch of things to say about this. First of all, I've been fighting for the last decade to get back to improving it. It has many problems. They can be fixed. The track point can be improved gigantically, even now. And many of the prototypes I made did have haptic feedback in them. They had sometimes adaptive transfer function, so they would work better for different people, and so on. So I'm sorry it's not better. I want it to be better. I haven't had my hands on it in too long. It's my fault. I left IBM. So, well, back in 1983, there was a brand new book called Human Computer Interaction. It was written by Tom Moran and Stu Card. And I was reading it right when it came out, and I saw that there was this work done by Bill English and Stu Card that showed that a mouse could make selections much faster than other input devices. And I didn't understand why, because as one person at Xerox said, mouse proves that man can draw with rock. So I looked, there was a piece of literature it referred to, and it showed that in the first 15 minutes of use, people were better with a knee bar, moving a knee bar like you have on an old time what do you call it, sewing machine, than using a mouse. And I thought about that, And I thought, that's weird. I wonder if it's because while I was a cognitive scientist already, while your knee has almost no dexterous control, and your finger has so much,
Mm-hmm.
that maybe before you've learned how to use your finger to do this pointing, not taking your hands off the keyboard might have a big dramatic improvement. And I wanted to test that. And so this was 1983, and I was actually working at Stanford, and I had this idea of a pointing device that would go in the keyboard. And at the time, it was going to go in the thumb area. And I wrote a patent right before I went to Atari. And at Atari, I worked on mostly other things. But then I wrote down this patent idea that I actually had an issued patent as I went to IBM, and as one of the things I had previously. And that they said, well, don't work on things have your intellectual property on, until my colleague, a friend I met rock climbing, by the way, Joe Rutledge,
Mm-hmm.
said, of all the things that you talk about, I would rather work on this pointing device with you. And he was sick of being a mathematician, hadn't been very productive for a while as a mathematician in IBM Research, might be 20 years. And so I retaught him how to program, because he was a logician, and retaught him some electronics, because it'd been tubes when he was a child that he learned about. And we started doing this, and it took several years to get it into product. But there were so many things we learned. For example, the thing that was really interesting is I published a paper in 1989 at Interact where I showed that a nonlinear transfer function could make a big improvement in how fast people could select. And it was, there's a long story behind it, but the interesting thing is that was the same year that at the same conference that Stu Card wrote a paper saying that nonlinear transfer functions are terrible. And so he and I sadly didn't get along for quite a while, because while I showed that if you don't go faster than the eye can track a cursor, you don't lose it. That was what I learned.
Mm-hmm.
Very interesting story about why we found that and how we found it. But he thought that people couldn't control things that they couldn't have a mental model about. Well, we got 30%, 20 to 30% performance improvement by not letting a person lose track of the cursor on the screen. And we got another almost a second of improvement by not having to take your hand off the keyboard to the mouse and back to the keyboard. And between the two of those, you could edit while you're text editing, you could edit so much faster than even a trackpad. And there's reasons that the trackpad did well, which have to do with IBM tried to be very, 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 very proprietary about this TrackPoint, and people got sick of they were chasing us down, wanted to use it, but we wouldn't let them use it for a while.
Just the idea of all the time that you're saving, and it's one of those things where you're like, oh, but it's only a second, but you need to add that up every time you're making that transition. And I think I remember seeing an interview that the distance that you measured was actually quite significant if you actually went back and forth that many times, how long that hand is actually traveling while you're
Yeah,
making
and
these transitions.
the main thing is it's taking your attention away from what you're doing to have to find that mouse. And in fact, my very first patent, which I should have done something more with, was maybe it was the second, but anyway, it was making a stylus
Mm-hmm.
that you grab and doesn't fall over. Because a mouse, one of the best things about the mouse is that it doesn't fall over, but it doesn't let you use all of those 47 or 46 muscles in your hand so dexterously.
Mm-hmm.
And so I actually made keyboards where between the space bar and the wrist rest, there was a stylus sticking up that you could wiggle, that was on a track point. And, it was delightful because compare that to a Wacom tablet where you have to go and,
Mm-hmm.
pick up the pen and then put it in your hand and then work with it. Of course, you're not going to replace your mouse with that because it's a lot of work to pick up a pen.
Mm-hmm.
But if it's already standing up, you can get that beautiful dexterous thing. Anyway, so there's a lot. I mean, whatever topic we go to, I'll probably talk about frustrations of things I coulda, woulda, shoulda, but also, ways that people can think about things, hopefully in ways that could end up improving things still.
No, and I know that you opened up our conversation with saying that you were kind of sorry that the track point wasn't better. I think you're too hard on yourself in some regards there. Like it is a pretty fantastic piece of kit, especially for those that take the time to explore it. Because a lot of people see it and they're like, well, I just won't use it. It's there, but I don't have to. But for those that actually do spend a little bit of time with it, I think they can immediately appreciate it. Like even an amateur touch typist um, can immediately see benefits of not having to take their hand off of home row if that's the only thing that they get from it.
Right.
So
It's interesting because the sad news is any of you use it with Dell, the Dell one, they purposefully, for a long time anyway, didn't listen to my explanation of why it didn't work well. And I think they did that on purpose because if if people are devoted to this thing on an IBM, and at that time IBM did not put a trackpad on their keyboards,
mhm.
if they can get them away from it, then they can break people's addiction to ThinkPads. Um, I'm still addicted to ThinkPads, and it's not that I can't use a trackpad,
Mhm.
but I definitely get the value out of using my track point. And I am proud that I'm still able to do it.
No, and you should be. I know that you've talked a bit about some of the prototypes that you've done with the track point. Like you've had the stylus stick on the
Yeah.
end. I know that you've mentioned there was a keyboard at one point that you were experimenting with that had two track points. Were there any other kind of experiments that you did with TrackPoint that maybe you wished would have saw a market or maybe continued?
Well, there are dozens of them, but
Yeah.
one of the most interesting things that we learned with the two track points, I might have one around, I don't know. Anyway, was that instead of putting them symmetrically
Hmm.
for the two hands between the J, K, and M, and between the D, F, and C, for example, we put one of them we offset them in some of the experiments. And what we found is if they were in different positions relative to each other on the different keyboards, you could remember which one was which much better. So you wouldn't get confused be by the artist often moves a piece of paper around with one hand and marks it up with the other. So that's an example of what I wanted two track points for. This there were several versions of this mouse
Right.
that came
Yes.
out, and the big news for that is we actually wrote a paper in Chi, ACM Chi, that showed that you could go that if you wiggle your finger, it doesn't it's a gas pedal and you can go forward, as
Hmm.
opposed to rubbing a wheel, which is you have to do continuously. So
Hmm.
it was 30% faster to scroll with this
Yeah.
and than a wheel, and you could go diagonal, right? Because it's a joystick, you
Yeah.
don't have you can go horizontally. So we went to Microsoft and they said, yeah, that's fine, we saw your paper, but we're making a two-thirds of $1 billion a year on our mouse, so we're not changing. And we went to Apple with the track point, and they said, well, that's branded IBM. We don't really want something that's branded IBM in our laptops. So that was awfully frustrating. But But no, we put the track point in a handle that was used by the air traffic controllers,
Oh,
and that was a big help in us getting a big contract with them. We put so that they could control. With one hand, they could control. They wouldn't have to have their big keyboard. They could just
yeah.
select which airplane they were talking to, and then they had a. I actually have a special invention for a button that would allow them to talk to the voice reco or the airplane or both.
Oh,
It was
that's cool.
kind of, yeah, it was cool. And then the thing that I think got away that I really loved was we put it in a laparoscope so that a doctor could control their camera with their thumb, not have somebody else have to control their camera,
Mm-hmm.
because they could do it right on their surgical instrument. And that was tested at
Wow.
Johns Hopkins, and it was beloved. And we didn't have the bandwidth to make medical devices at that time for them. But I'm sad about that. There's many things I'm sad about, but I shouldn't really whine, because we made some things that lots of people got to use. And the most interesting thing about um, a lot of it is that um, I found out that people with disabilities liked it more than almost anybody. So people that had shaky hands, there's a whole bunch of things in our algorithm that are trying to understand how not to overshoot. So for them, it was even bigger. And then we made a little attachment to it for a mouth stick
Mm-hmm.
so that you could use it with a mouth stick. And that people loved a lot too. And I'm looking, I don't know, I'm not going to find it, but we made a little, because it has this big analog to digital converter in it, just to show it off, I made this little thing you could snap on it, which would let you play with all sorts of physics experiments. So, you could go on a swing, and a pendulum would show what your acceleration was back before accelerometers were in every phone, and you could measure weight. It was just this offset that would pull down, so you could put a letter in it. It'd measure how many stamps you needed on it, and we could teach pendulum motion by putting a quarter in this thing and sliding it up and down and seeing how the pendulum changed its frequency. And you know we even made some games where you could see if you put a weight over here, it mattered more because of the lever arm, and if you blew on it, you could see 1/2 height times width, because it's a triangle, would make how much force it was. And so I worked with the education group at IBM trying to make this into a teaching tool for physics. So I don't know if I'm on the topic you're asking about, but
No, no,
that's,
no, absolutely.
yeah.
No, for sure. And it makes total sense because I don't think a lot of people really understand just how precise the track point is through how it's designed and how the software of the computer interprets those movements. Like they probably just think it's nothing more than like a simple joystick. And it's like, no, it's way more complicated and awesome than that. And I would have to say that people are still figuring out the potential that that thing has.
Well, just to give you an example, there's a gesture language built into the firmware. And so the idea was that, if you, the how you put your pressure on it, we made a whole language so that it would be possible to just use the track point to do all these gestural things, to make things happen. And we tried to expose it. I doubt it's easy to get your hands on it from any software place on your computer now, but maybe it is. So that's yeah. There's a little gesture language built in, and if anybody asked me, I probably could go dig up what the I think you send 2 characters to it, an A1, for example. I don't. It's a long time ago, but I have to go find out. But yeah, so there's a whole gesture language built into it, and then at one point, I wanted so badly to make the thing vibrate that
Mm,
one of my cutest ideas was back before stereo. I took the speaker, and you could still do it with one. I took the speaker and put it right underneath the track point, and then I put a little. I modified the speaker with a little piece of plastic on its voice coil, and then I made some electronics so that it would, if you sent it a signal at a low frequency, you could use it as a solenoid. And so the same piece of hardware, the same speaker that could make high fidelity, had this little pin sticking above it that you'd never run into when you're making noise. But if you ran that voice coil, bam, up against it, you tap the finger, and I got that
Wow.
all working. And then when that didn't make them happy, then I designed a TrackPoint. This is 140 thousandths of a diameter, that post coming out of the strain gauges, and I built a coil into it and put a fancy magnet in there, so it became its own solenoid. And then, so I didn't like that as much. I was much more proud of this speaker turning into a solenoid than, because that literally only costs a transistor, where we're making a real solenoid in that tiny post. It's a little more expensive, but in any case, I never got those ever got into product.
Mm-hmm.
But I'd love it.
No kidding.
Yeah.
Oh, that's
And
fantastic.
in fact, what was impressive to me is we came up with this whole understanding of what makes sense to feel. So if you're just going zoom across the screen, you don't need to. You're 30,000 feet. You don't need to feel the texture of every pixel that's on and off. When you're coming into a window at a slower speed, you kind of want to just feel that there's a scroll bar, but not the details of that. When you go into the scroll bar, right, then you feel it. Or when you're looking at the text, you feeling every character is interesting.
Oh,
And
wow.
and I had so much fun thinking about this. And one problem I have of being honest is that I did a little study. I don't get around to everything, but I do some, that showed that for learning, the haptics was very important.
Mm-hmm.
The problem is that for learning how to use a track point, you learn within 45 seconds, you're better than a mouse for text editing. But after 40 minutes, you're better than a mouse for everything. And the point is, well, so if you get better than everything in 40 minutes, why do we need this haptics? Let's not waste the money on it.
Mm. I don't know. There would be something about the user experience, though. Like just how you're describing it to me, I was thinking they need to do that. Like how great, like what kind of level of human interactivity you could add by just having that,
Oh,
that tactile feedback.
oh yeah.
And like I'm sure that it could easily be done, probably more so now than even back then when you were experimenting with it.
It can be done easily. I mean, does it add 50 cents to the product? Probably. It probably costs that much more. Um, Here's a funny piece of thing that I learned at that time. So I brought ones where the rubber top vibrated, and I made ones where there was a pin that stuck through the top and touched your finger. And I showed it to blind people.
Mm.
And which do you think the blind people liked better? Did they like the dull thud or the pinprick?
I would, I'm gonna take a guess that would be the pinprick.
Well, you were right, and I was wrong. I thought it was going to be that was going to be too, I don't know, too intrusive.
Hmm.
They liked that so much better. They wanted the precision, and it's interesting. They were, and by the way, they had more consistent feedback than the able-bodied people. Yeah, so you're
Hmm.
right. Yeah.
Yeah, that was a hard guess. The only reason I went the way that I did is I was thinking to myself, if I were in that situation, I'd want to be certain that that's what I was touching.
Exactly. Your intuition's right, and I was shocked. Um, and just in terms of data, which you're going to hear over and over again, I once had I made something called Car Coach at MIT, And I had a student that was studying it, and it had these two levers on the dashboard, one for affirmations and one for criticisms. And he collected data about this. And a few weeks went by, and I said, well, "Where's the data?" "Oh, I'm not done. I was analyzing it. I really, and it kept going that way. And finally, he leveled with me. He said, "Look, I was really worried that because it turns out that every time we gave criticisms, people started making more mistakes driving. They'd be mad because you'd put all this work into thinking that criticism was as important as affirmations." And I said, "Wow, that's really interesting." And he was like, "Oh, so you weren't completely tied to your hypothesis?" And I said, "No, of course not." um, and I think that most of us, most of the time, have these whole confirmation bias things built into what we think about. And it's very difficult to be, or maybe it isn't. I don't know. For me, it isn't so difficult as some people maybe, but it's important to be expecting that your hypotheses aren't going to be correct. And otherwise you don't learn very well.
Very wise.
Yeah. So the poor guy, he got criticized for not showing me that criticism wasn't useful.
Oh, the layers. We've mentioned it a few times already. ThinkPad, very iconic brand, just recently celebrated its 30th birthday. From what I understand, you were there pretty near toward the beginning, and obviously helped introduce the TrackPoint to it, which is still with it to this day. What was it like getting involved with that project?
Well, there are a whole lot of things to say. I mean, the biggest bragging I can possibly do is that the difference between the product that had no TrackPoint and the one that did was not speed, resolution, or size or weight. So they're both the same every other aspect. And the difference was the TrackPoint. And the one with the trackball, we made 10,000 of them and didn't sell them. And we'd been having that trouble with laptops for years, that we'd make 10,000 of them a year and not sell them out. And that one, the TrackPoint in it, went from us not losing money, tens of millions, by the way, a year, to making selling $500 million worth of them in the first year. And it took us a year and a half to catch up to demand. So you couldn't buy them because we only were, Allstate, if you were at, KMPG or Allstate or some Exxon or something, you could probably get one. And at one point, I wanted to prototype something which I'm very proud of. You take off the lid, you use the LCD as a projector. Anyway,
Yes.
and everyone said that couldn't be done, and I couldn't get any from production because there was not enough of them, and so I went over to Stanford bookstore and bought 4. Was it 2? I think 2. And I was able to get it at Stanford, well, kids were buying apples, right? So at certain places there'd be a few laptops around, so I went over and bought it retail, brought it into the lab at IBM, and proceeded to destroy it. By the way, I didn't. I made it work. And my favorite moment with a cognitive scientist was when I walked up to Don Norman at a party, and I showed him that I'd taken this laptop and made it so you could take the lid off to let the sunshine illuminate the display, saving 20% of the power, or put it on an overhead projector. At that point in life, every conference room had an overhead projector. So that was a kind of a special thing. And I remember him saying to me, "Well, they said that couldn't be done." And I said, "Yeah, they told me that too." He was at Apple at the time. He was the VP of he was the vice president of research and development at Apple. So I was very proud of that moment. um, and we went to product and made a lot of money with that product, by the way, and they shut it down within a year because for political reasons. So that's a whole story too. Lots of things, that have made some impact, some have made longer lasting impact. It's a tough business trying to change anything.
Yeah, absolutely. So obviously part of a huge success story. Like from the bits and pieces that I've gathered, like they were actively seeking some kind of pointing device. Like how did you get dragged into it? Did
Yeah.
somebody tap you on the shoulder and be like, "Hey, we heard you're working on something"?
Yeah, that's a very interesting question. I mean, first of all, they had a trackball and thought it was great.
Right.
And by the way, I'd been trying to get this. For example, the first place that I got commitment was from banks that said that the mouse took up space on their in their real estate, their downtown real estate. If they could put a track point in their computers, they could save space for the tellers. And they had this big order in mind. And I took that big order to the PC company. They said, we're not going to do that. So I had many cases where people were told even by upper management, because I had shown this around and gotten a paper accepted, and a lot of stories about the difficulty of changing anything in a big company, where the people that were actually doing things. Let me just say, the group that was supposed to evaluate TrackPoint in the PC company, they had a name for it. The name for the project of testing out whether TrackPoint was useful or not was called Castaway. So it was really, I mean, the uphill battle was severe, and maybe I had the courage and stamina to keep doing it because I was working on my PhD thesis, so it was a nice diversion. But in any case, your original question was, did they tap me on the shoulder? And what I'd gone and I built it into some of the earlier laptops to show off the idea. I'd written this paper. At one point, they didn't let me publish it because they didn't want, for 6 months, because they were worried that I'd be giving something away, but they wouldn't use it themselves. That I actually threatened to quit. I said, I'm going to publish this, and you can fire me anyway. And what happened is it showed up in Business Week, and that changed everything for a little while. So getting it in required many approaches to pushing. But in the end, what was important to them, well, I'll describe a meeting. Okay, so there was a human factors guy, let's call him Yamada, wonderful man. And he'd done this study where he was working with a vendor, Alps. And Alps had a trackball, and he'd been working with them. And so he ran a little study that showed that the track point was slower than the trackball. And I came to Japan, and I showed that for that one particular scenario of using it for the first 30 seconds, the trackball was better. And I showed that there was a learning curve. And then I pointed out on his spreadsheet that he focused completely on the first 30 seconds.
Ooh.
And I did this in public in front of his management, which is terrifying because it was the first time I was ever in Japan, and I didn't want people to lose face. So I started off by saying, the research you guys did here is the most precise, carefully done work on TrackPoint that anybody's ever done. And it shows that for the first 30 seconds, when somebody just starts using it, the track point isn't as good. But here is a graph that shows the timeline of all the experiments that have been done all over the world by different laboratories in IBM, showing that it's a learning curve. And after 45 seconds, you are better with the track point. And I had this whole demonstration that after 40 minutes, you're better than even a mouse. By the way, you're better than a mouse for some things after 45 seconds, but not for just continuous drawing.
Mm-hmm.
But the mouse isn't great for continuous drawing either, so we're better. So that, so anyway, that was a really big breakthrough, except that the management said, take that, and both of you have to give the same talks to the next layer of management. So over the next 3 days, we gave that same talk, both of us, him talking about what was bad about the track point, and then me talking about how that was one particular regime 3 times. And the person that made me make that graph of learning curve was my manager's manager, actually, a guy named Ashok Chandra, who's gone now. But he was my biggest mentor in my career, very, very important to me. He always pushed me, often showing me where I was wrong, by the way. Anyway, really amazing guy. But so getting through that gauntlet was really scary. And what they said at the end is, okay, Yamada and Ted, you must work for the next week. And if you don't show that you can make it as good for the first 30 seconds, then it's out. And so you have to work together to do this. And
that's interesting.
And that was really scary. At the time, the top of the track point looked like that. And I thought you had more precision with a good connection, a little bit back to your intuition. So I tried all, and I also liked it being small because I was very concerned about it taking up space on the keyboard, getting in people's ways. I am flabbergasted that we were successful, and that's a whole nother story of finding a place on the keyboard where it wouldn't get in the way of a touch typist typing. And I'm sorry for all of you guys that aren't touch typists, but somehow that hasn't been the thing that people complain about. So good. So I went over to a place called Tokyo Hams, and I bought cork and sorbothane and ping pong paddles, and I tried every sandpaper. I made so many track point tops, and I had Yamada test them all so that he became part of the story. And at the end of the week, we had actually demonstrated a whole bunch of things that could be done to make it work. And it had to do with the exact durometer. That's how flexible the rubber is, so that you could feel it. So there was some compliance, but not too much compliance so that it would move too far, and that takes time. And then a grippiness for your finger, which I was worried about. And we solved that problem. And then, the manager of the ThinkPad stood me up in a hallway. I remember this forever. And he stared at me and said, Selker-san, you make us do this. You must not let us down.
Ooh.
And I really felt like it was the dagger. He was saying, you're now tied to this. And we see that there's lots of problems that are going to need to be solved in the next year before this goes to product, next 9 months. And you probably don't see them. And he was right. So they put just on the software side, they put a person full time on testing it on all different softwares. And sure enough, our driver sucked and this and that. And there's lots of mistakes and problems along the way. And so it was quite a ride, getting that thing to be good enough. Yeah.
It's just one of those things that, how how does it get from where you had it through all of those managers and then ultimately, getting on to, a ThinkPad and then, getting that top, the very first one,
Yeah.
which kind of looked more like an eraser now, if I remember right.
Yeah, the first one, quite frankly, that we made that we were really proud of, it had a polyurethane 50 durometer, 55 durometer wiggly thing, and then it had on top of it that air suspension that you get on a really good quality ping pong paddle. It had I
Okay.
cut those little pegs down to make them even shorter, so it had better, didn't wobble so much. And then that's very sticky rubber on top. That was the one that really, the first time I made something that was good, it was that. And then we had to then that for various reasons they said they couldn't make it that way, of course. And so then quite yeah serendipitously, while the IBM Center for Competence for Rubber said
Hmm.
that they couldn't get a sticky rubber because they were worried about it being, I'd use latex and that's not FDA approved. I called up my father, who is a chemist, and he'd worked on rubber earlier in his career, and I was very upset because they wanted to use something that was slippery. It's called
Mm.
Santoprene, and slippery won't work, right? And my father said, "You got to be kidding! Condoms are made out of latex."
Yeah.
So that was one of my special moments, and I hired him. And the Santoprene slippery ones were on the first 6,000 machines that they sold,
Oh.
and they were injection molded, and they started crumbling,
Mm-hmm.
and they were slippery. And within 2 weeks, the one that my father and I designed, with um, what came online, and there's a lot longer story about this, and it was put on all of them and retrofitted to all the ones that had been put out, and nobody heard about it.
Yeah, I was gonna say, like, this is brand new information for me too.
Oh yeah, so basically, the if we hadn't have fixed those,
Hmm.
it was 10 weeks before product announcement that I actually got money to make the injection mold. I mean, to make the molds to make these rubber tops, because everyone was blocking me in the product team because it was going to cost more money.
Mm.
And if I hadn't have succeeded at that, we'd have no product. But then there's so many stories about that like that. I could tell you about, sulfur on the anyway, a whole bunch of them, and we could go through them all. But the point being that making something work that is new has a lot of subtlety sometimes.
Oh yeah. Yeah. And a lot that you're probably not even aware of until that moment in time when you're like, aha, we've made it. Oh wait, we didn't think it would do that.
So, for example, they changed the formulation of the rubber, and it had a lot of sulfur in it, which made the strain gauges start evaporating off of the post.
Huh.
Yeah, that's an example of a problem we came to. So these
Wow.
kind of problems, I want people to think and know that manufacturing engineering takes as much creativity as anything else, and that it is devalued in many circles of researchers. And I think that it is uh, fascinating. How do you, so, for example, if you have time for another quick story,
Yeah, yeah, yeah.
so Philips, we were the biggest customer for the chip that we used on our on the TrackPoint, because we were selling, I don't know, whatever it was at the time, million a year of these or something. Um, and they called me up and said, "Well, what can we do to help you?" And I said, "Well, you know, I would love it if I could have a 16-bit A-to-D converter, because half the cost is your chip and half the cost is our A-to-D converter." And they said, "Well, but I know you can't do that." Yeah, we can't do that. And so I had, on the spur of the moment, as I sometimes do, an idea. I said, "Well, we only need 8 bits of that to be fast. So what if we use a capacitor to charge up to make the other 8 bits and just slowly change that with a capacitor and a comparator while we make the 8-bit A to D converter in your thing do its thing. And they said, oh, we could make that. Well, that took the electronics to half the cost.
Wow.
And it made a lot of money for Philips. So Philips then actually partnered with us and became we gave them the authority to sell this chip to other companies to make TrackPoints. It was a little bit late. And they were so happy with this that they put in a full-page advertisement in Wired magazine about our collaboration. Which was, that was one of the honors of my life, of course. Here I'm a user interface person. What the heck do I have doing inventing an A to D converter?
Well, if you know what needs to be done.
That's right. That's what I realized when I realized, my God, these guys are literally willing to change the silicon for me. Wow. And gosh, can I think of anything they could do? Well, what if they could do that?
Yeah.
And the guy was like, let's do it.
Obviously, you had an awful lot to do with making sure that TrackPoint was successful on its launch and making sure that the first ThinkPad was successful on its launch. But I think not very many people are aware just how many other innovations you actually brought to that lineup. And I was wondering if there were any particular favorites of yours personally that you kind of had your hand in during your time working with the ThinkPad brand.
Well, it's funny that they don't seem like a big deal, but they were at the time. So it turns out that none of the laptops had wrist rests. So there was no place to put your hands. And so I recognized that if you have your hand on something, you have more control of it than if it's hanging off of all the way to your shoulder. And it was a big difference. So I couldn't get them to move the keyboard back. They said it was impossible for a whole bunch of reasons. And so I started doing things like the fanciest thing I ever did is I made this filigree keyboard cover that was 1/4 of a millimeter thick polycarbonate plastic with a frame underneath it. And you'd take it off the keyboard and you'd snap it together, and it became a little wedge that snapped onto the edge of your laptop and gave you a wrist rest. And I made so many different kinds of wrist rests, but that particular one, I think, finally just drove them crazy, and they moved the keyboard back. So that took me almost 5 years to get them to change where they put the keyboard so we'd have a place to put your hands. The ThinkPad 760 has a keyboard that tips up. That was something I designed. Putting the camera up at the top of the display, I prototyped that. For years, I showed ideas of even integrating a CD player that would snap on the top of the laptop with the disc spinning in the air. But the main reason I wanted that there, because you can make a disc player that was smaller than a disc if all you really need runs the center and then a head. So I showed that, trying to get the disc into the computer, but also I was intent on getting a camera, and that camera now is everywhere. This is a very early plug. The first place you saw this particular kind of plug, although I made the first ones, I'm sure, was on an Apple, where it makes the power supply smaller. In fact, this might even be the first time I made one. You can see it's built out of epoxy and 2 plugs.
Right.
In the end, I did a whole lot of things to try to make the power supply smaller. There's a lot. I don't know if I have one of the good ones, but anyway, making one of these things that hinged allowed it to go into any kind of plug strip, which was something I was really proud of. But then I showed them if you made a short plug, you could do the same thing, only you could even twist it. So for a long time, we shipped a power supply with a very short cord that you could put into any plug. But there was a whole lot more I did with the power supplies. Quite frankly, I wanted the power supply to be part of the laptop.
Mm-hmm.
The documentation, we had a book that came with every laptop, and that book was very expensive. The packaging was on the order of $12,
Okay.
and triple that if you want to say what it costs by the time you pay for it in the store.
Mm-hmm.
So I came up with this idea of of wrapping paper. And the wrapping paper was, when you opened the laptop, it would reveal what all of the different features were by having the documentation on those features. And that doesn't seem radical today, but at the time it was radical. And it really reduced our help calls when we started doing that, because people could find what things were for, like how do you put the battery in? Very
Right.
hard to teach if you don't show them. But also, one of the first things we did is we made a animation of how to use the TrackPoint, because when my brother got one of the first few laptops and his TrackPoint wasn't working, it was because they had, for the first several bunch of them, they hadn't put a driver, they forgot to load the driver, and the repair person says, "Oh, that isn't for a pointing device. That's to keep the display from hurting the keys." So somebody did that. It's made. I mean, getting people to communicate correctly is difficult. But the thing that I did that I think was also important and was part of the product for 15 years at least, was an interface that replaced the rows and columns of buttons to set up your IRQs and your serial ports and all of that crappy stuff that set up your printer. I made a version which was a rotating laptop. You could rotate around a 3D laptop, see all of the ports, touch the port, and by touching that port on the GUI, select the settings you want to use it for. And that was a really well, again, it reduced the help calls and the service gigantically. There were other things that I was involved with, not so putting a heat pipe in the laptop, I was part of that. I wasn't the only instigator of that, but a heat pipe allowed for a while for us not to have a fan when everybody else had a fan.
Mm-hmm.
I made some changes to just the frame to make it stronger by using better materials. I made a bunch of demonstrations of leather and other things. I wanted to have a crush zone at the edge of the laptops. I have a bunch of prototypes of that. That came out in one laptop called the Transnote.
Oh, yes. Yeah.
Yeah. That was a big fight. And if I hadn't have been spending my time at MIT at that time, it would have been a good, I would hope it would have been a better product. I also, fought for a lot of things that made it less expensive to manufacture. At one point, I made a keyboard that was a quarter of the thickness of the keyboards we were selling, and had a lot fewer parts. And while that didn't get into product, it got into prototypes, and it changed the way we were deciding how to work with the vendors, which made our keyboards get much better. Same thing happened to a lot of my ideas about power supplies.
Mm-hmm.
While not all of my ideas, like I designed a transformer that would actually was the cord, so it looked like a cord, didn't get in, but it changed the way we designed our things. So a lot of times I would make prototypes to demonstrate new ideas, and they would instigate something. An example is keys. We had a on one line of keyboards. We I was able to get things in sometimes because if you made something for people with disabilities, no one could fight you. So I made a key. I made some keyboards where you could use one hand to set and make selections. And it was
Okay.
a piece of hardware that actually had a mode. It was the 755 product that had these in them. And and what happened was while that didn't last, we put a much bigger effort into other disabilities things. So if you look at the blue button in the center of the TrackPoint buttons, that blue button had two purposes. Number one, if you press it, it changes the mode, so it's like having two track points. So that's where the two track points went. It's like when you press down, now you can scroll with it.
Mm-hmm.
So it's like having a second track point. So that's a big deal. But also, when you press down, it can be a magnifying glass. That's for people with disabilities. And so that when I showed that, it made a big difference. And I don't know. I mean, I could go on and on, but just things as simple as the shapes of the buttons had to change. I mean, an example of subtlety that breaks things was we started off with 220-gram pressure on the buttons. All the
Right.
keys have 60. And the 220 grams is from cars. Cars have 220-gram because you're in a moving thing. Well, getting that reduced helped not just the keyboard, but it also helped the mice we were making.
Mm-hmm.
And the industry now has much softer keys on all of the mice. So, I mean, there's 100 things that didn't get in, but I had ideas that, yeah, whatever. You can only what. By the way, my experience is that kind of 1 out of 10.
Yeah.
That's about as good as I ever got. And I was very discouraged by that until I found out that mostly nobody gets anything in.
Yeah, 1 in a 10 isn't so bad when you look at the odds next to you, I suppose.